let's say you have a get user endpoint. So you want to test if actually, if I call this endpoint, it will actually get me the users from the database and the data I need from the database. Probably maybe you've mapped it to your DTO classes, your payload, and the rest of them. You want to get the exact specific data, just so that you are sure that you have integrated it from your API level down to your service level and the rest of them, database level and the rest of them. Now, end-to-end test, right, is where you are testing the full flesh of the application. Let's say you want to test from login down to the getting of the user. So you want to test if, can I log in? Okay, if I log in, am I authenticated? Am I able to use that my authentication, maybe token or something to call secured endpoints? Are these secured endpoints actually working? Can I, do what I'm supposed to do? So you are doing it end to end, right? So that's another form of testing which you want to do. Probably you do these things with QAs and the rest of them. So let's just understand unit testing. So unit testing is just the practice of testing individual units of or components of code in isolation. So like we said, you are isolating them, you are testing them bit by bit. So a unit is typically the smallest testable part of an application, usually a method or a function, right? So that method you've written in your service class, that method you've written in your repository classes, whatever method or function you've written, right? You have to like test them bits in bits. When you test in bits, you are basically doing unit testing. So when you test in bits, you are sure that okay, it's just like building a house. You start from ground level down to the up level. So when your methods are working as required, that is when you cannot progress to something higher, right? So that's why unit testing comes first. So the characteristic of unit testing is they are isolated, right, which you say, and they are very fast, right, because you are testing in bits. They are repeatable. Why are they repeatable? Because you might want to test a method with different scenarios. So let's say a method is calling get users, for example, like we use. So you want to test with different scenarios. Okay, well, what if there are no users in the database? Does the method return users? Is not supposed to return. So you want to test when there is no user, when there are two users, when there are one, right? And maybe when there are multiple, is it paginated and the rest of this so that it can be repeatable. So it's self-validating. So it passes or fail without any mutual interaction. It doesn't have to depend whether another unit testing is failing or not, right? So it's self-validating and it's timely, right? So is written close to production code creation. Yeah, that means when it's not normally being done when you are building. It's not until you have built that is when you do unit testing. So you test as you build, right? That's how it's normally done. You test as you build. You don't build everything and start testing, and then if you get an issue, you start going back, right? So that's that actually the flow that is supposed to be. So just a sample of unit test that we have. So let's say we are testing a method that calculates the total price, right? So this is just like the way where you are the way or the manner you're supposed to actually name your tests, your unit testing. So you want to name it in a way that you understand what it's doing, right? Easily. So looking at this method, you already know that we are actually calculating the total price, and you want it should return the correct sum. So that is where repeatable comes in. So I can also create another method that actually calculates the total price, but then I don't want it to return the correct sum, just to test that okay, this thing is actually working. And the flow that we normally use, there's 3 A's that we normally use in testing, which is the arrange, the act, and the what's it called, assert. So the arrange is the fact that you are doing your mocking, right? You are creating your objects, you are creating the constructor to actually inject data or inject objects into that particular service class or object as the case may be, or entity as the case may be, just anything you want to test. So that's where you arrange your data. So as you can see here, we just created an object of other service, and then we are creating item and new items in a list, right? And then this is where we are acting. So we are calling a method in our service class to actually calculate, right? So we've created the object of the service class, even though that in a normal scenario, we are not going to create our object here, right? We are going to mock it and inject it. So we are just doing this as sample. So we are calculating it, and this is your answer. So you have acted, right? This is the actual thing that method is actually supposed to do. So now that you have acted, so you are now asserting, right? So the answer that you've gotten from your method, is it the same thing as this, right? So this is the answer you've gotten. So you want to assert that when you multiply 10.00 by when you add 10.00 with 2.50, are you going to get this 12.50 as your total, right? If there's anything other than this, that means your method that you've written is not correct. So for the next part, which is the integration testing. So what is integration testing? So integration testing verifies that different components, right, or services of our application work correctly when combined. It tests the interfaces interaction between integration tests. So in integration tests, we are testing in bits. But now in unit tests, rather, we are testing in bits. But now in integration testing, we are testing the different components or services. So in nutshell, let's say we are testing your endpoint, right? It could be your endpoint, it could be any other thing, right? So for example, your endpoint, let's say your add user endpoint, you want to test that from the controller class, the endpoint or the method that represent that endpoint is actually calling probably your service or your facade or your helper class, and that helper class or service class are actually doing all the business logic, and they are calling or they are persisting or retrieving all the data they're supposed to do in the repository layer and the rest of them. So you are actually connecting all the bits together to show that they're actually working end to end. This is not end-to-end testing, right? But this is just integration testing, right? So uh, a simple example about integration testing is where we have like a controller integration test class that we see here. So here we are we are injecting our mock MVC here. So what this method do, right, exactly, is to call these endpoints. This is my system. So what this endpoint do is to call this endpoint, which is this API slash users, right? So this is where you have your mock MVC in action. So mock MVC helps you perform mocking of calls as if you're actually making a call. It could be a get, it could be a post, it could be a put, patch, and the rest of them, right? So it could be any kind of method. So you are actually mocking it. They are not real calls. So the endpoints, they are not actually real, but in Spring context, right, they are actually real. So they are mocking it for you. So they are like giving you like tests endpoint just to see if your endpoint that you actually created or the code you actually wrote that represent these endpoints are actually working as you want them to be. So we are actually making a post call to this endpoint, and we are setting the content type to application.json. So it could be anything. So you have to set your content type, and then the content, which is like the body of the what's it called? The body of that is your request body. Okay, so your request body is like Samuel, and then that is the name and the email. So this is the request body. So now when you call this endpoint, what are you expecting from this endpoint? What is probably like the status code, the response body, the response header? These are things you can expect from a post method. You can expect status code, response body, response header, and so on. So for example, status code, now we have this. So we are expecting a status code of is created, right? So which is a 201, right? And then a JSON part. So this is just like an example. Okay, probably we are like expecting that an ID will be returned when we create this user. So this is just like a sample. So you could expect more things than this, right? You could expect more things. So you could want to test how your request headers are coming, how your request bodies are coming, and your status codes are coming, and so on. There are a lot of things you can actually test, right? So that's for the integration part of the testing. So, but then why do testing matter in today's industry? So the business impact of testing is that you have cost reduction, customer satisfaction, competitive advantage, and faster time to market. So finding bugs early is cost reduction, so that you don't have to go into production, you come back, you go again, you come back, because you are not actually testing your work. You are just pushing to production, and it's costly doing those things, right? So you actually reduce cost, and then customer satisfaction. You don't have to have a lot of production bugs, and customers are complaining that I can't buy, I can't pay, my card is not working, I can't make payment. Imagine having these things on your, probably your POS money point machine. So you have a lot of customer dissatisfaction, and then we don't want to have that. And you could lose customer because of this, customer trust and the rest of the competitor advantage. Like I said, trust. People will no longer trust that and network are not so good at the rest of this. So faster time to market, automated test, rapid and confident release. You are confident that, man, this your release is in the market, and it will work as you want it to be. The technical benefit, right, is code quality, right? It forces better design and architecture. I mean, somebody that is coming into the system will actually, know how quality your code can be, and they can be able to be sure that even if they are adding any new implementation, is not breaking the existing implementation. Documentation, right? So it serves as a documentation. So we could actually use it to even onboard a new engineer, right? By showing the person what this endpoint can actually do from start to finish, and the engineer will be fine. And then refactoring safety enables fearless code improvement. Exactly what I said earlier. So when you are creating or adding new improvement, you are implementing a new changes, you are sure that your change has not breached the existing one or other implementation. So when you add the new changes, you must add tests to those new changes. So even if we have an endpoint that is already working and has been tested and the codes have been written, if you are making any change to that particular endpoint, you must write a new test case for it. That's just the way it goes. And then it's essential for CI/CD. Yes, of course, if your tests do not pass in maybe Jenkins build, code deploy and code build and all those stuff, it will break, right? So GitHub Action and the rest of them. So you must include testing, right, in your pipeline, so that doing CI/CD, when you are doing your continuous integration and delivery, that those tests will actually run, and if they fail, it will not be deployed, right? Like it will not be delivered to the production environment. And then industry statistics: companies with mature testing practice deploy over 200 more frequently. Well-tested could have 50% fewer defects in production, of course. Automated tests can reduce QA time by 70. So what this is saying is that, for example, right, you could have like a service that has over 100 tests. Just so you want to run just your one test, you run over 100 tests. And because of the fact that you guys are deploying like frequently, it has to be tested just so that you are sure, right, that when this thing gets to that environment, it does not break, right? Your defects are reduced. Is not a guarantee, right, that there will be zero defects, but you are sure that your requirements are actually met, right? And your back and forth with QAs are reduced. They just do their stuff, and it is solved 100%. 2055. Okay, so problem solved by testing. Let's just go. Fear of change. Without proper testing, you will be having this fear of change, hidden bugs, technical depth, integration nightmares, and deployment anxiety. I mean, these are things that we must have experienced, right, during our cost of working for a team, right? So you have this fear because you didn't have a proper testing. If you have your proper testing, you won't have this fear. But with comprehensive tests, you have confidence in your changes, early bug detection, clear requirements, aggressive prevention, and continuous delivery. So with your comprehensive test, you can be assured that these things are in place. You are sure, you are so confident, you have detected your bugs early, and you have your clear requirements, right? So common testing frameworks and tools that we normally use. So just going to be using Java or Spring ecosystem. So we have a lot of testing frameworks out there, right? A lot of them, right? So, but I'm just going to be using the one I'm kind of familiar with, right? So for unit testing framework, we can use JUnit 5, all right? So Mockito and Assault J. So probably maybe all of us here might be familiar with this, because I believe, or I think that maybe most of us here are Java inclined, but there are other unit testing frameworks out there. It's not just this here, right? So this is just the standard Java testing framework, right? So this is the our mocking framework that helps us mock objects that are not real, right? So, and then these are Assault J that helps us do the assert equals, assert true, assert not true, and the rest of them. You are just asserting just to be sure. You want to assert that your results and your let's say your which was the right, so your result and your expectation, yes, your result and your expectation are actually, they are actually correct, or they are actually aligned together. So then for integration testing tools, of course, your Spring Boot test, which is once you create your Spring Boot application, it normally comes with Spring Boot test by default. Test containers, which are like real database testing with Docker. You have a Docker container that holds the database instance, and it gets destroyed immediately your test is. You don't have to manually, handle them. Once you handle them in your testing, I will also show an example of that. Rest assured, this is for API testing library. Wiremocks are when you are doing like HTTP service visualization. This is okay. I think I have an example of this wiremock, which I will show later. And then additional tools, right? So Selenium for web, Cucumber, Jacoco. So these are actually additional ones that are not used when you're working mainly on unit and integration testing. So this one is when you are doing like behavioral driven development. You want to test your API speed and the rest of them. You can actually use additional tools as well. So some essential testing annotations that we have. So for JUnits, which is for unit testing, so we have a test. So it just marks that method, that this method is a test case, right? So if you don't have this at test annotation, Spring context, right, will not regard that particular flow or that particular method that is encompassed, even if it's inside that test class. It will not run as a test, right? It will not run as a test. So that's why you have this at test, at before each and at after each. So these are normally used when you want to run setups before your testing actually occurs. So this will run in Spring context before your actual test runs. So it runs before each test method, and then after each runs after the test method. So this basically, for example, maybe you want to create all the instances of the objects you want to need. You want to ensure your database is up and running. These are examples of things you want to do here. You want to create you want to instantiate a class, and feed that class with fields that you want to fill. And then after each are things that you want to do after a test runs down. So probably you want to, for example, you want to shut down the database, you want to flush it, you want to delete, you want to expatiate, and the rest of them. So there are a lot of things you can do in after each. Before all and after all. So for the before all, it runs just once before all tests in the class. So before each test, it will run. When that test runs, it will run again. So it runs once, right, before all the tests in the class. So once it runs that one time. So, and a good example, a good example could also be, say you want to use one instance of database. You don't want, and you want to have a database instance that is shared across all your test case. So once that runs, right, it will be used across each of your test cases, or your test class in your uh, application, right? So then the after all, right, once after all the test classes after all the tests in the class. So right, so this is just like is similar with the after each. So this one is each, right? So but this one is after all. When everything has run, this is when this can actually run, like database deletion, or maybe you want to extend it and the rest of them. And then we have, these are like common stuff that we use, right? So these are like display name. So there's another one called display name that you can add to your test method. So you want to, let's say you wrote this test method name as test premium discount, right? But you want it to be displayed differently when your testing is running, so that you can follow the logs and the rest of them. So you want to use this to give it a special name that you want to actually identify with, right? It's just like you are using Swagger to do your documentation and the rest of them. And then the parameterized tests, right? This is another annotation that is being used very well. So parameterized tests is you want to pass different parameters to a test method that accepts an argument. So if your test method accepts an argument, so you can use the parameterized test to pass different arguments or values or parameters to it, right? So you can have different values used at runtime at different times. Do you get? So Spring Boot test, we've talked about this one. This one loads the Spring application test for integration test. So this is mainly used for integration test. Likewise, the web MVC test. This is, of course, this is used with Spring Boot test, but we know we do use this one when most times we want to run APIs, right? You want to test APIs. Why this is when we want to test repository classes. I have some of these examples which I will just show before our time elapse. Yeah, so then we have at mock bin and at spy bin. These are like, at mock bin is the normal stuff, right? Which is like you want to inject a service object during runtime, so it will help you inject or create this object of user service during the runtime. So it will create it and then to inject it into your application. But at spy bin can be used interchangeably with at mock bin. So it depends on the case where you, in case you meet at spy bin, there are some applications where you can have at spy bin, right? But they are being used in, it depends on how your service class are running. If your service class are using like Facade and utils and the rest of them, those are like stuff, but the one that is mostly used is at mock bin. So I just added it here just in case you come across it. And these are like the, okay, this thing break, these are like the configurations, the at auto configuration mock MVC. So you want to auto configure some things you want to use in your application. And then your test configuration, let's say you want to configure the database values, username, password, and the rest of them, at mock and at inject mock. Okay, yeah, this at mock is when you want to inject or mock a user repository. These are mainly used for repository layers, right? And then at inject mocks are, you know, used as well for repository layers as well. You can use them interchangeably, but at mock it's mainly used more often than at inject mocks. So the best practices and testing strategy, which I already discussed this, right? Which is you arrange and then you act, then you assert. So you arrange, you create your objects, inject your objects, you act, you call the APIs or you call the methods, and then you assert. You have to now check these calls that you have made, this check that you have made, right, for your methods or your APIs. Are they doing what you want them to do? So one assertion per test, yes, you have to like keep your test focused. You don't have to make it that bulky. So you can always have one endpoint to have like 10 different tests, 20 different tests for one endpoint, just so that you are keeping them as focused as possible. And then you give them a very descriptive name, just so that you can, know what their test is doing or explain the test. And then test behavior, not implementation. Yes, focus on the outcome. That's where your assert come, right? Not really what you implemented, right? But what is the outcome, the behavior of that particular thing that you are testing, right? So in testing, we don't really care about the implementation of your code. So if you want to improve your implementation, you can go back to your codes and improve your implementation, maybe increase your response time or the rest of them and the rest of them. So keep tests independent. Yeah, no test should depend on another test. Of course, no test should depend on. So you can know the one that is breaking and the ones that are not going through. So, but for integration tests, of course, using test containers is the ideal, right? These are real database over using in-memory database like H2 and the rest of them. So always use test container. They are like the ideal. That's the industry standard way of using database mocking. So clean state, of course, we set database between tests, test happy and edge cases. Yes, you don't want to always test the one that you feel that will work. Try to make it break. Do the ones that will not work. Like I gave an example, then we're doing to add two numbers. So you want to also put something that is actually not correct. So you want to do assert true, assert false, right? Assert not true, uh assert not equals. You don't want to always do assert true, assert true, assert no. Now you can always test your edge cases and see if they fail, right? So that is what that assert not true comes into play. Assert false comes into play. Those test cases will pass because your edge case, right? Your edge case are actually working. So it means your edge case are being caught. Do you get? So mock external services, of course, you have to like mock external service. You don't have to, you have to avoid dependency injection, right? So did I say you have to avoid? You have to avoid direct dependency injection. You just have to mock it because if you do it direct, is in spring context of test. It's not your main application that is running, right? And then performance awareness. Integration tests are slower, so you have to use this widely. Yes, I've seen integration tests that actually took over 30 minutes running. You get so everything depends on your application that you're testing. So you have imagine you have an application that has over 200 endpoints, right? And you need to run the test and be sure that every endpoint are running. So these are tests that you just run and you just keep your machine and you just gonna be doing something else, right? So test coverage guidelines, yeah, target 80% of your coverage is generally good. Yeah, you want to ensure that you are covering almost all the implementation that you've done, right? So that's 80%. Focus on logic, prioritize business logic over getters and setters. Yes, you have to prioritize business logic over getters and setters. You don't have to be testing if your objects are actually returning what they are supposed to return and the rest of them. Quality over quantity, of course. 100% coverage doesn't mean bug free. Yeah, that's true. That's true as well. So you want to be sure that you are testing your edge cases, you are testing what is required to be testing. So it's not all about having multiple tests, whereas you are not actually picking what you're supposed to pick. So for real world, okay, for real world example, okay, I actually created let me get so I actually created just a simple I just created a simple library application, right, which I just quickly did just so we can just have like a test. um okay, all right, so this is just the overview of the application, so I can only share this if you want. So it's just like I just built APIs for managing these, some of the basic things we all know, right, or we all use. So the handles, book catalogs, and the rest of them, student registration and the rest of them. So this like what it does, and the some of the business logic and some of the endpoints that are documented here. So my main focus is to ensure that I'm able to create test cases for each and every one of these endpoints that are here, right? For the both book controllers and the library controllers, I want to actually test every of them. So that was what I actually did, so that we can actually see that your entities as well. You want to ensure that your repository classes are actually working as required with your entity. So we'll be testing those as well. And then these are the repositories. So these are the service. We'll also be testing our service layers as well, right? So I will not want to start going into the intricate of. I mean, this is just a simple application. It doesn't do much, just your basic code, stuffs, right? Get, post, puts, deletes, find, fetch, like every other stuff, and then other intricate things as well, like find by, available by, search, update, and the rest of them, right? So now, of course, when writing your test, so we have like our test um folder, right? Where after this is where you write your normal Java code, which we all know. But then you need to, if you want to write your test, so you come to the test folder, which is under the test, then Java, then you create a method, and it is always advised if you are testing for your controllers, right? For example, you are testing this is just like a simple system. You can have a more sophisticated stuff like this. So, but imagine when you have a sophisticated stuff, so you don't want to get confused, really confused. So you have to ensure that for controllers you are naming them just the way it's been named in your main application. You don't want to come in and be giving them a different name in terms of your packages, right? So you want to ensure that if I go to my book controller, I'll be able to tell. Is it a meeting time?
Yeah.
Okay, okay. Let me just, okay, 15 minutes. All right. So you want to be able to tell that, okay, this boot controller, this is where I can find the test case of the boot controller, and I can be able to go through it and see that, okay, all my test cases are working. And then if you can see for this example, almost I ensure that I touch almost all the annotation that was explained, right? Auto configure mocks, Spring Boot test, before each test, and the rest of them. I just try to, touch some of these things, and then I actually went through some of these endpoints and just try to test them and generate some test cases. And likewise for your library, right? You do the same thing. You have to like, let me slow down a little bit here. So you have to like, create tests. So if you check in my before each, I'm trying to like delete some of the stuffs I've added. If you see my repository, so I'm deleting them. Okay, did somebody raise up their hand? Okay, all right. So I'm deleting them, and I'm creating new objects of book and subject, and I'm saving them again. So I'm just reusing the same thing. So before each, I'm running something. So I just wanted to do something that at least I'll be able to use this here, right? I also wanted to use after each, but nothing was coming. I just skipped that and just did the before each, and just moved on. And then for the control, for the repositories as well, so I created an abstract class that just handles all the configurations here, static configuration, right? So you can see that I don't want to be recreating test containers over and over again. So I just have like my dynamic properties here. Yes, I didn't explain this. Dynamic properties help you to create your containers. You give them the URLs and the rest of them. So that's just it. And then these are the service classes where we can test. And if you want to run your test, you can either run it on your command line, or you can run it from here as well. So you can just play this and your test. That is if you want to run the entire test. Then if you want to run them individually as well, right? You can just come here and just play any of them, or you play any of the test methods that you have here, right? So this will just run in the background and it will test everything. And right, so we have like 67 test cases, right? And everything passed, right? So yeah, that's just it, right? So thank you very much.
Wow, wow, wow. Uh, Max, thank you very much. So I guess we've all learned a lot. I have. And there's something you mentioned which is correct, which I see a lot of developers no longer follow, which is TDD, test driven development. Most people actually do that these days, and you actually just hit the name on here. So thank you very much. We are honored to have this lecture from you. So I'm not going to take much of our time because of we don't actually have time. But before we take one or two questions, I'd like to appreciate some persons here that are actually driving the Naija Java user group in Nigeria. So Java user group is a worldwide community of Java developers. Yeah. So what we have here is just the Nigeria version, which is the Naija Java user group. Uh, so, but we have people that are driving this community over in Nigeria. So I want to take some time to appreciate them and um, call them to just maybe one of them to give their vote of thanks before we take one or two questions and we'll call it a night. So part of the backend team, we have Tochukwu. Tochukwu, just use the emoji. Tochukwu is there. It's part of the backend team of the Nigeria Java user group. We have Samuel, also part of the backend team. Then there is Abdagej. Yes, it's also part of the backend team, as well as my humble self. Then why the pioneer? Yeah, the major person, the pioneer that is in charge of directing us is Gloria Barayega. So Gloria, please can you just unmute and give vote of thanks and maybe one or two information you want us to hear based on things, yeah, that will be rolling out from the Nigeria Java user group in the nearest future. Gloria, please take the floor.
All right, thank you very much. Thank you. I really appreciate. Guys, you didn't just stay calm? Let's react to what we just benefited this evening. It's not easy. In fact, at some point, I could not take notes again. I said I will just wait for the record, please. Let's just react. It wasn't easy. And I want to thank everyone for making this section a success. And firstly, I want to thank our guest speaker for making it very impactful and insightful. We really thank you. And we just wish, and we are just saying that this is just one section of many sections we are going to have with you. And for those that are on the call, for from the Java user group, we normally have lightning talks on Tuesday, and we also have monthly sections where we have speakers to come and speak. So we are expecting another section on Tuesday, and we also expecting someone, but it will be reviewed to the house. It's been settled, and then we are expecting to kickstart our boot camp. Although we plan starting it September, but we are still trying to structure the curriculum and all of that. So we are pushing it to next year. Please bear with us. So we will give you the best we can. And for those that have not joined the group yet, I shared the link to the group in the chat. So you can join the group so you can have access to the record of this section. Let me just stop here so you can ask your question. Thank you for making this night a success. Thank you so much, Sashegu, my boss.
Thank you, Gloria. We appreciate you. All right. So please let's ask. So just take at most 2 questions, depending on how brief it is. So if you have any question, please just raise your hand. Please just try to make it brief. Bright, bright. Shiwi. Sorry if I murder your name. Sorry, but bright. Yes. Ask your question.
Hi, good evening, everyone. Can you hear me? Hello?
Yes, we can hear you loud and clear.
Okay. Thanks, for this great talk. So I actually have, a question, for example, you have a team of, for example, junior dev, right? How do you ensure proper test coverage? Like, how do you ensure, that you say that, okay, tests, it kind of solve a lot of issues, right? But I believe that if it is not well covered, we are still back, to that same shithole that we are in. So how do you ensure a proper test coverage? Yeah.
All right. Thank you, Max. Over to you.
All right. Thank you very much, Mr. Shegun. Bright, thank you for the question. So, quickly, right, you mentioned that okay, you're a junior developer, you are in a team, right? So probably, let's say for example, you are giving a task to say, let's say, create an endpoint and the rest. So to ensure you are actually covering all the edge cases or proper coverage like you asked, you need to ensure that your tests, right, are meeting all the requirements that is needed for that your implementation. Now, when you are giving a task, right, there's actually a goal to it. So let's say, for example, let me give a basic example that I always use, get user, for example. So if I want to cover the test or all the coverages for getting a user, I will test whether, okay, fine, am I getting users? One, am I not able to get user when there is no user? Two, am I able to pass a specific ID and I'll get that specific ID of the user? Are all the records that are coming from the user correct? So it's all depend on the you as a developer. So there's no go-to call that this is the number of tests you can write. You can write as many test cases for a particular single implementation. It's just you trying to ensure that it comes with experience. It's just you trying to ensure that you are covering all test cases. So you now you might just write probably maybe let's say I'm new to testing, for example, and when I started working in okay, for example, let's just use money point for example. So I remember doing an implementation on the POS code base. So you have written the test and you feel you have covered all edge cases, and these QA guys can just come and just test a particular edge case that you did not handle. But but it will not be as severe when you did not write test at all. So if there's an edge case, it should just be 1 or 2, and you can easily just go back and do that. But imagine you didn't write at all, you didn't try to at least cover your ground. You'll be having like over 15 test edge cases that you did not even handle, and that's not a good call, right? So even if there are edge cases, it shouldn't be like 1, it shouldn't be more than 1 or 2. So that's how best you can handle these things, right? So yeah.
Thank you, Max. Brilliant. Thank you very much, Brighton. I hope that speak to your questions. All right, Rosemary, I see you are here. Rosemary, unmute your mic. Just to be sure you can hear me. Rosemary Uroko, unmute your
Yeah,
mic.
that answered my question.
Hi,
Though
good
I have some
evening,
follow-up,
everyone.
but
Oh, yeah,
to
okay,
allow
Bright.
others
Sorry. Please, you can maybe drop your question on the chat. We'll forward it to Mark. We don't have time. We're actually out of time because the meeting ends in 4 minutes time. So we can't take more questions. Please bear with us. Hopefully, in future lightning talks we might extend the timing. So Samuel, I'm going to give you Rosemary contact. Yeah, she's going to be one of our speakers one of these days. She's also good. She's good at what she does. So Rosemary, I'm actually committing you right now on this call. I'm going to share your contact with Samuel. He's going to reach out to you, schedule a date for you, and you come and speak to us. Come and teach us what you are doing in that place that you are working.
Hi, thank you very much, sir. I really appreciate it. And thank you, Onyekachi. You did amazing job. Just a quick one. I remember before I got my job, I got a call from, I think, the engineering manager of the team. And the first question he asked me was, are you familiar with TDD? Courtesy of my boss and my mentor, Mr. Oseki Shegun, I knew what it was. And that was how I got my first job with little interview. So thank you very much. Take your testing very serious. I sincerely appreciate it. God bless you.
All right. Thank you. All right. So just like Grace, yes, if you have any question, please share it on the WhatsApp group, and Max will do it to respond to your question. All right. So we meet again next week Tuesday. Please keep grinding, keep believing, keep improving, and the sky will be your starting point. Bye, everyone. Good night from Java User Group.
Bye.
Good night, everyone.
All right, bye. Thank you.